Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn some properties of cyclic quadrilaterals. In the earlier video, we have seen what a cyclic quadrilateral is, what are the basic properties of cyclic quadrilateral. Today, I have a question here. Is or else what is a cyclic parallelogram? What is a cyclic parallelogram? A parallelogram whose all the vertices lie on a circle is going to be called as a cyclic parallelogram. Here, if at all, this is a parallelogram, what can it be? In particularly, what is a quadrilateral is the question here. What is a cyclic parallelogram? Here, A, B, C, D is basically a cyclic quadrilateral. I have told you that it is a parallelogram. So, opposite sides are parallel. If we remember our earlier videos, we have seen what are all the properties of quadrilaterals. All the types of quadrilaterals, we have seen all the properties in detail. If you want, you can refer those videos. This is a cyclic parallelogram. Opposite sides are equal and opposite angles of a parallelogram are equal. Right. Now, this is a cyclic quadrilateral. So, opposite angles are supplementary. So, here we have two properties. Opposite angles are equal, opposite angles are supplementary. Let me assume that this is x and this is also x because it is a parallelogram. Angle DAB plus angle DCB is equal to 180 degrees. Angle DAB is equal to angle DCB. What are the reasons for these two properties? This is because it is a cyclic quadrilateral. This is because it is a parallelogram. Now, I am going to combine these two. Now, angle DAB is equal to angle DCB. Therefore, angle DAB plus angle DAB is equal to 180 degrees, or 2 times angle DAB is equal to 180 degrees, or angle DAB is equal to 180 degrees by 2, that is 90 degrees. So, these two angles are equal to 90 degrees. Similarly, we can prove that these two angles are equal to 90 degrees. That means this parallelogram is a cyclic parallelogram and we have clearly observed that all angles are going to be equal to 90 degrees. What is a quadrilateral what is a parallelogram whose all angles are equal to 90 degrees? It is definitely going to be a rectangle. So, what is a cyclic parallelogram? It is nothing but a rectangle. Every cyclic parallelogram is going to become a rectangle. I quickly repeat the proof. We are given a cyclic parallelogram. I proved that it is a rectangle. What is my approach here? Opposite angles of a cyclic quadrilateral are supplementary. I have written the statement here. This is the reason. And because it is a parallelogram, opposite angles are equal. Therefore, these two angles are equal. X plus x is equal to 180, 2x is equal to 180, x is equal to 90. So, these two angles are going to be 90 degrees each. Similarly, let me assume that this is y, but these two are opposite angles of a cyclic quadrilateral. Similarly, 2y is equal to 180 or y is equal to 90 degrees. All angles are equal to 90 degrees. So, a parallelogram becomes a rectangle if all angles are equal. Hence, every cyclic parallelogram is a rectangle. Now, we have learnt what an isosceles trapezium is in the earlier videos. An isosceles trapezium is a trapezium in which non-parallel sides are equal. Let us consider, let us not move on to the conclusion immediately. I am going to give you the conclusion later on. This is an isosceles trapezium. Right, an isosceles trapezium is a trapezium in which non-parallel sides are equal. Right, A, B, C, D, these two are equal. Because it is a trapezium, one pair of opposite sides are parallel. These two are parallel. Hence, these two are going to be supplementary. Right, these two are going to be supplementary and these two are also going to be supplementary. Okay. But in particularly for an isosceles trapezium, the base angles are equal. That means these two angles are going to be equal. Okay, these two angles are going to be equal. X, X. This is Y. Let me assume this is Z. Later on, we'll see what is going to be the proof over there. Now, observe carefully that X plus Y is equal to 180 degrees. Reason? Or else, in particular, angle DAB plus angle ADC is equal to 180 degrees because co-interior angles are supplementary, but angle DAB is equal to angle CBA. Reason? Isosceles trapezium. This is an isosceles trapezium, so the base angles are equal. This implies angle CBA plus angle ADC is equal to 180 degrees. That means these two are supplementary. When will it happen? In a quadrilateral, if opposite angles are supplementary, then it should be a cyclic quadrilateral. Or else, in other words, a quadrilateral becomes a cyclic quadrilateral when its opposite angles are supplementary. Here I have proved that angle CBA plus angle ADC is equal to 180 degrees. Therefore, every isosceles trapezium is a cyclic quadrilateral. So we have learned two theorems here. The first one is every cyclic parallelogram is a rectangle. We have used opposite angles of a cyclic quadrilateral are supplementary and opposite angles of a parallelogram are equal. So we have proved that all angles of a cyclic parallelogram are 90 degrees, hence it has become a rectangle. Now coming to the next one, we have considered an isosceles trapezium, and I have proved that every isosceles trapezium is going to be cyclic. How is it going to be possible? Every isosceles trapezium has the base angles equal. I considered two perpendiculars from D and C on to the base AB. DM is perpendicular to AB, CN is perpendicular to AB. Now I have to prove that the base angles of an isosceles trapezium are equal. The proof is going to be very simple here. These two angles are 90 degrees. These two heights or these two sides of the two right angle triangles are equal because the line segment DC and AB are parallel. Two lines are said to be parallel if the distance between these two lines is the same at any place, at any point, right? So DM is equal to CN. Now AD is equal to CB because it's an isosceles trapezium. Therefore, triangle AMD and triangle BNC are congruent by right angle hypotenuse side RHS. Therefore, these two triangles should be congruent. Hence, corresponding parts of congruent triangles are equal. Therefore, the base angles are equal. This is a proof for base angles of an isosceles trapezium are equal. Done. Now, we are considering an isosceles trapezium. I am going to prove that every isosceles trapezium is going to be a cyclic quadrilateral. To prove that a quadrilateral is cyclic, I need to prove that opposite angles are supplementary. Here, these two angles are supplementary because it's a trapezium. In a trapezium, or for instance, two parallel lines are there, then the co-interior angles are going to be supplementary. This is going to be x, for example, then x plus y is equal to 180. But these two base angles are equal. If these two angles are supplementary, then these two angles are also going to be supplementary. Hence, I have proved that opposite angles of a cyclic quadrilateral are supplementary and opposite angles of an isosceles trapezium are supplementary. Therefore, it should be a cyclic quadrilateral, right? So, we have proved two theorems here which are going to be considered as theorems of cyclic quadrilaterals. In the coming videos, we are going to learn many more theorems. Thank you.